writing a mass balance equation for the chain reaction. So for the reaction of CH3CHO to produce CH4 plus CO. So this is the stoichiometric equation. Okay, given in the question is the stoichiometric equation, and the rate equation is R equal to KCA power of 3 over 2. Okay, if you look at the rate law equation, it is not elementary equation. Based on the stoichiometric equation given, the rate relation is not elementary, because the power of CA is 3 over 2. Okay, then next, the mechanism of chain reaction and its rate law equation is given as the following 4 steps. Okay, so the stoichiometric given is the overall reaction, but how the reaction occur, it is based on the mechanism of reaction, meaning that the reaction not directly will produce CH4 and CO. So it will go through step by step. Okay, how the reaction occur. Why we call it as a chain reaction? Because there are an intermediate reaction occur. So let's say, so if we assume that reactant A is CH3CHO. So for this example, okay, reactant A based on the stoichiometric equation actually CH3CHO. So we simplify it as a species A, reactant A. Okay, so it involves 4 steps of reaction. The first one, so if you look at the mechanism, the first mechanism, so right, step 1, step 2, step 3, and step 4. So the first mechanism is the reaction of A to produce 2 radicals. So the steps that produce the radical species, we call it as a initiation step. Initiation. Okay, because reactant A will produce a radical CH3 and radical CHO. Okay, and then second step, the reactant A will react with the radical species to produce CH4. So from the stoichiometric equation, CH4 is the main product. So the step that produce the main product and also the side product, okay, based on the stoichiometric equation, we call it as a propagation step. So the second step is propagation. Alright, and from step 2, okay, reactant A reacted with radical CH3 to produce product CH4 and another radical species CH3CO. Okay, but we still call it as a propagation because the product CH4 produced. Alright, then next step, okay, the other radical CH3CO will react to produce another product, which is CO, and another radical species of CH3. So this step, because the reaction also produce the product, we call it as a propagation step. So from step 2 tadi, it is propagation step 1. Step 3 is propagation step 2. Okay, and then finally, 2 radical species, which is CH3. Radical species CH3 will react with each other to produce another side product. But this side product is not appear in your overall stoichiometric equation. Why? Because it is inactive product. So, inactive product. So because the reaction between the radical will produce inactive product, so we call it as a termination step. Right. Then for each mechanism steps ataupun for each steps of reaction, so we have 4 steps of reaction. We need to write the rate law equation for each steps. And rate law equation for each steps of a reaction is elementary. Even though the overall rate is non-elementary, but the rate law equation for each steps of reaction must be elementary. Okay, elementary rate law. So, elementary rate law. Okay. For the first step, okay, because all the reaction is irreversible. So, for initiation step, Ri equal to Ki, concentration of A. Then, propagation step 1. That's why Rp1 equal to Kp1. Rate constant for propagation step 1. Okay, concentration of A, concentration of radical CH3. Okay, and then propagation step 2, Rp2 equal to Kp2, concentration of a radical CH3, CO. And finally, for termination step, rate law equation is Rt equal to Kt, because this is termination step. So, Rt equal to Kt, CH3, radical CH3, power of 2. Why power of 2? Because it is elementary reaction, and if you look at the number of mole of CH3 here is 2. So, power of 2. Because we assume that the order of reaction is equal to the number of stoichiometric coefficient for elementary rate law. Okay. Now, the first step, we need to write the mass balance equation. Let's say we want to write the mass balance equation for PFR. Okay. For PFR, so general rate law equation, we know that negative dCi per dt equal to negative Ri. Okay, this is the general mass balance equation for PFR. This is this equation you have learned it in reaction engineering 1. Okay, now we need to write the mass balance equation for each species involved in the reaction. Okay, the active species, only the active species that involved in the reaction. Okay, first, we need to write the mass balance equation for species A. Okay, species A. So, if you look at the mechanism, so we write the mass balance based on the mechanism of reaction. So, based on the mechanism, species A involved in step 1 and in step 2. Okay. So, saya tulis kat tepi. Involve in step 1 and 2. So, and then first step. In the first step, A disappear. Second step also, A disappear. So, for disappearance of A, negative dCA per dt equal to, so the mass balance we write it based on the rate law equation. That's why we need to write the rate law equation for each steps of reaction. So for species A, negative dCA per dt equal to KIA. And then second step, A also disappear. So plus KP1 AC CH3 radical. Okay, or you can rearrange the negative sign as dCA per dt equal to negative KIA minus KP1 ACH3 radical. So kita positifkan at the left hand side, right? This is for species A. Next, we look at the radical CH3. So, we need to always look at the mechanism of reaction. So, for radical CH3, so it will involve, CH3 involved in step 1. Step 1, CH3 appear. Step 2, CH3 disappear. Step 3, CH3 again appear, and step 4 disappear. So meaning that radical CH3 involved in all steps of reaction. So involved in step 1, 2, 3 and 4. So they involve in all steps of reaction. Then you need to look at which step the radical appear and disappear. Okay. So for the first step, so radical species CH3. So dCH3 per dt. So we want to write it in terms of concentration. So in bracket. Bracket meaning that the concentration. So CH3 in bracket dt. Okay, the first step, in initiation step, CH3 appear. So it will be positive. KIA. Then for propagation step 1, CH3 disappear. So minus KP1A CH3. Okay, why dCH3 per dt positive compared to A? A is a reactant, but CH3 as a intermediate product. So that's why positive. Okay, then we continue with the mass balance. So step 1 done. Step 2, CH3 disappear. Step 3, CH3 appear. So plus KP2 CH3CO. CH3CO. And then last step, in termination step, CH3 radical CH3 disappear. So minus 2KT. Why 2? Okay, look at the stoichiometric coefficient of CH3 in termination step, 2CH3. So maksudnya mass balance, because we write the mass balance, so we need to consider it as a number of mole. So minus 2 KT CH3 radical power of 2. Okay, because the order of reaction based on rate law equation. Okay, so this is for CH3, radical CH3. Okay, next for radical CH3CO. Okay, so CH3CO appear in propagation step 1. and then disappear in propagation step 2. So CH3CO only involved in second step and third step. So involved in step 3, step 2 and 3. Right, so the mass balance dCH3CO per dt equal to propagation step 1 appear, so Kp1 A CH3. Propagation step 2 disappear, minus Kp2 CH3CO. Okay, and then so we already write the mass balance for 3 species, 3 active species. Okay, next for the product. Okay, later I will explain why radical CHO kita tak tulis. So now we look at the product. For product, CH4. So CH4 appear in step 2. Okay, only in step 2. Because it is main product. So dCH4 per dt equal to, so in step 2, so product appear, so it's equal to Kp1 A CH3. Okay, kenapa saya tak expresskan concentration in terms of symbol C? Because there are too many species, hydrocarbon species, so ada carbon. C tu adalah carbon. So nanti later you will confuse, banyak sangat C. So that's why we write the concentration in bracket. Okay. And then finally for product CO. For product CO CO per dt equal to CO only in step 3, which is equal to Kp2 CH3CO. Okay. Alright. So that's all. The mass balance for all the active species. Okay. Why I'm not writing the mass balance equation for radical CHO that only appear in step 1, and also for the side product C2H6 that only appear in step 4. So it is not compulsory because radical CHO, radical CHO, it is inactive radical. Okay, and product C2H6 inactive product, which is very low in concentration. Inactive product. But if you want to write the mass balance equation for these two species, it should be no problem lah. So it's up to you. But for me, it is not compulsory. because dia tak involve in the reaction, and it is not the main product. It is just a side product with very low concentration. Next is mass balance equation for CSTR if the reaction occur in CSTR. Tak banyak beza. The difference is when you want to express the mass balance symbol tu for CSTR, the mass balance is in general CI0 minus CI per tau. Okay, this is for product. For reactant. Okay, for reactant. But for product, the general mass balance equation is CI minus CI0 per tau. This is for product. Okay, saya bagi satu contoh. Mass balance of reaction in CSTR for species A. For species A, okay, for reactant A, okay, in concentration A0 minus CA0 minus CA lah maksudnya, divide with tau. So it's equal to, so the mass balance actually similar. So the difference is yang at your left hand side to show that it is mass balance for CSTR, and at the right hand side still the same. So KIA plus KP1A CH3 radical. Okay, so sama je. And then this is for reactant A. For product, okay, so kat sini, so highlight star kan, this is for reactant. For the product, let's say for radical species, for species CH3 radical, the mass balance equation in CSTR is CH3 radical minus CH3 radical at initial. So divide with tau. And it's equal to, so KIA minus KP1A CH3 radical plus KP2 CH3 CO radical minus 2KT CH3 radical square. So the difference is at at your left hand side saja, because we want to show it is mass balance for CSTR. So for the other species pun sama. So just change at your left hand side equation.